Okay, we're going to be taking a look at PI's batch processing script. But first, let's open one of our subs. This is the Heart Nebula IC1805. We're going to perform the usual processes that you should know by now. Automatic stretch. Zoom in with the mouse scroll wheel. Then you press the space bar and now you can move around the target until you get the detail you want to see. Click this small icon here, it zooms to the extents of the heart, and again you can zoom in with the scroll wheel on the mouse. And just position it using the space bar again. Now let's go to scripts and let's open the batch process script. So here you can see batch processing. This is the script we're going to be using today. This script performs automatic calibration and registration of your files, but first you need to add those files to the script, and here along the bottom you can see add files, so add bias, add darks, add lights, etc. So let's add the bias. Now I normally just go ahead and shift click these files and then say OK. So there's the bias files, first one to the last one, shift and say open. And now the bias files are now registered with the script. That's the darks. There's the darks, select them all and then say OK, open. And now the darks are registered with the batch processing script. And flat files. Flat files are located with light files. So let's just find them now. Yep, go down. There's the heart, and there's my flats. I've got more flats, of course, because flats are easy to take. Say OK. So now we've got the bias, the darks, and the flats registered. So now we just need to register the lights, and there's the flat files, all 25. Now the lights. I've only got 9 because of the clouds. It wasn't a fantastic night, but I managed to get just over an hour and a half of lights in H alpha of the heart. And there they are. Once you've done all this, you need to select a reference image, so you can just double click one of the image files and that'll now become your reference image for the image registration. Output directory, so I just choose the lights directory and select that one, it's OK, and then run the script. There's a couple of little warnings there, but you can mostly go ahead. It's just going to rename to H alpha, so that's fine. Continue. And this warning is important because it says that the script isn't really optimized for your final image registration. You can go ahead and use it, but I prefer not to. The script actually takes quite a while to run, so you could probably go away now and have a cup of tea. One thing I should point out is that I had a great deal of difficulty locating and running this script. In my version of PixInsight, it hadn't updated correctly. So in the end, I deleted PixInsight from my system, re-downloaded the latest version, and then updated that version. And finally, the batch script, or the batch processing script, became available in the script window. So you may also have some similar problems. There are some solutions on the PixInsight forum for you to check out, but I found that a reinstall and a re-update solved all my problems. You'll see that the batch script creates some intermediate files. It creates your master dark, your master bias, your master flat, etc. They pop up and disappear in between, and you can see the registration process going along. Well, first calibration, then registration. But as I said, it takes some time, so we're going to speed things up. I'm going to cut out approximately 10 to 15 minutes of processing time, and we're going to jump ahead to the part where we can view the output from the script. A few more intermediate files there, and now we're going to jump ahead. Okay, we've jumped ahead now. It doesn't look like it to you, but we have jumped ahead. We've lost about 10 to 15 minutes of processing, and this is coming to the end. And the script window will finally open, or the script window will pop back open in the screen, indicating it's finished. Here we go, now we're finished. So I don't do any integration with this script. It's not optimized for integration of your final image. So essentially now I'm going to close this script and finish. Yeah. So let's compare a calibrated frame with an uncalibrated frame. So let's go and open a calibrated and an uncalibrated frame. First the uncalibrated, and of course an automatic stretch. Should be getting familiar with this now with the screen transfer function. There you go, that's our uncalibrated frame. Let's open a calibrated. Now you'll see that it's automatically made a calibrated directory. So we take a frame number 7 again. This is now calibrated because it's prefixed with an _C. Open, and we can compare the two. And of course we're going to do another automatic stretch. What you're going to see now is the hot pixels have not been removed. So this calibration is really, it does calibrate your flats and everything else, but you'll see here that the hot pixels are still actually there, and that'll be taken out during the image integration. With the correct settings, of course. So you have to be careful with this script. Don't assume it's going to do everything for you automatically, because it doesn't, not at this moment in time. I think this is definitely an improvement that should be made to the script. I expected the hot pixels to have gone by now, but they're not, as you can clearly see when we zoom in. So we have the calibrated and the uncalibrated, but there you can still see some hot pixels in these two images, so they have not been removed. One thing that actually irritates me when I go on my soapbox is that people say before stretch they call it linear data, and after stretch they call it well, it's no longer linear data, but actually that's wrong. Any data that we receive is by definition not linear. Photons, when they arrive on our CCD camera, arriving in accordance with the Poisson distribution, and that is not linear data. Better term would be raw data, not linear data. Okay, let's do the image integration now. Well, actually I had the files here before, but I'm going to stop that. Let's clear the files and do it properly, as though we're doing it for the first time. Here we go, image integration, add files. Now we don't want the calibrated files. You saw two folders, calibrated and registered. So we actually need, they're the master files, we actually need these files, we need the registered files. These are ones where the registration between the images has already taken place, so we're ready to start these. I'm just using my normal presets here, and I'm using the WinRAR Sigma rejection with my standard settings, and I'm going to run that now. Again, coming back to the data, it is not linear data. It should be called raw data, because linear data implies the fact that if we receive 10 photons a second, in the next second we should receive another 10 photons, and in the second after that another 10 photons. But unfortunately our signal does not arrive so conveniently, so it's definitely not linear data. It should be called raw data. This process takes around about just under a minute, 50 seconds for me, and we should be coming to the end of it now. Almost there. Here we go. I actually like this process window so you can see what's happening and see it performing the tasks. And as usual, we have our three files, the high rejected, the low rejected, and our image. So let's take a look at all three. Auto stretch. There you go, that looks a mess, but don't forget that's from 9 files. And you can see in the top left corner there we've had a hit from an aeroplane, and that's been nicely removed. Let's check the low. There you go. Reject. And now the moment of truth, our image. And here it is, the Heart Nebula. This is the culmination of all 9 frames. Much smoother data, nicer detail. Let's compare it again against the original uncalibrated sub. So that looks very good. Of course, I mean, for me this object needs more time. It's just over an hour at the moment, an hour and a half worth of data. The detail is coming through nicely, but I will give this at least another hour when the weather conditions permit. But let's compare this against a single sub. Here we go, open, and you can see the huge difference. Auto stretch. Well, you can already see how much more grainy, but for a single sub it's not bad at all. I'm really pleased with this S Big. This is the ST 8300M monochrome camera, the larger size chip, and it's doing a very nice job. I'm really pleased with that. There you can see the centre of the Heart Nebula. Lot 15. Big difference, as you can clearly see between the 2 images. Okay, that's it. I hope you enjoyed this quick tutorial on the batch processing script. It's a handy function. It can save you some time. I recommend once you have this script running, go away, make yourself a cup of tea, come back when it's all finished, apply your normal functions, and you can leave it to run on its way, and it produces all the intermediate files for you, so you can go back and trace each step, and it performs a very nice job.